Today I'm going to be demonstrating how we can leverage the AMP catalog to deploy a LLM chatbot augmented with enterprise data. In particular, we're going to be using the Milvus vector database and an open source LLM model. From within the Cloudera machine learning suite, you can click on the AMP's catalog and see an option called LLM Chatbot Augmented with Enterprise Data. If you notice here, several different tags, of course, the primary one for today being Milvus. Whenever I click Configure and Deploy, I have the option to essentially specify a number of parameters that I want to include as a part of the deployment. In this case, this is pretty well built out, so we don't really have to specify anything other than the runtime. I'm going to go ahead and jump up to the latest runtime, take the other defaults, and go ahead and launch the project. One thing you'll notice is that there's pretty much nothing I have to do between now and the final application that gets created. We like to say these put you a good percentage of the way there in terms of creating an LLM application. Really the only thing that you have to add to this is your own data set. Here we're going to be using some docs from our public-facing website, which I'll show you in a minute. And since this will probably take about an hour to go ahead and download all the dependencies, spin up GPUs, download the models, I've already deployed one here, so we're going to be using that one. So this is sort of the page that you'll end up with once it's been successfully deployed. You'll have the ability to go ahead and open up that chatbot application. But a couple of the things that I wanted to call out here is from a Milvus perspective, what really happens under the hood. First off, we have to populate the vector database with the document embeddings. But before we can even get to that step, we needed to know what is the actual data we'll be using. So here I've just got some text data. If you notice, it's not very structured in that there's, there's missing spaces, there's multiple spaces. This is sort of one of the great capabilities of both vectorizing data as well as LLM chatbots taking the final data and processing it, is that we end up with sort of a cohesive response regardless of how the data was formatted. So there's about 10 of those in here, and what you'll notice when I come back up to the top level, that's going to be the data set that we're going to use to populate our vector database with. So for this one, we've downloaded a all mini LM L12-V2. Feel free to check this out on Hugging Face if you want. It's a embedding model, so when you end up loading it up, you'll see it's a sentence transformers model that can map sentences and paragraphs to a 384-dimensional dense vector space, and it's particularly useful for applications like what we're going to do, which is semantic search. So coming back over here, we've got the model downloaded. Now we're going to populate the vector database. Here we've got a vector database insert Python file. A couple things to take away from this is that we're going to create a Milvus collection. If you notice here, we've got a relative file path which points to the data directory, and then we've sort of mapped out the schema of which we're going to write. When we actually go about inserting the embeddings, you'll notice it's pretty simplistic in that we just take the text of the embeddings, or the text of the document rather, and get its embeddings, and then we pass that along with this metadata here that's particularly relevant as you want to know where the data came from. Think output not being hallucinated. I want to see exactly where the source was, because ultimately this is going to be the data we use to pass to the LLM model. So then we actually set up the base directory. Think of this as the collection. We start with our directory, add a collection over top of it called Cloudera ML Docs, and then we go ahead and spin up that Milvus database. Now, as you think towards scaling this, it may look like running this at a larger, through Docker, something like this. All of this you can do as well, but here we're just going to spin up a local Milvus instance, and this will allow us to generate those embeddings and deploy them. Now, one thing that Cloudera sort of excelled at in terms of this type of process is we've created a notion of jobs. So rather than you having to sort of run that multiple times, I can actually just populate the vector DB with the document embeddings. You'll notice a relatively small form factor size, 1 CPU, 4 gigs memory. And let me jump back to show you what it looks like under the hood. When we actually run that, you'll see that the Milvus vector database came online, and then we created embeddings for all those documents that I showed you earlier in the folder. So that means we've got 13 inserted embeddings, and so when we go and spin up our application, one of the things that I'll show you is the way in which you structure your query sort of derives whatever document that will be passed to the LLM model as part of that semantic search for a response. So like I said, the project creation succeeded. You'll actually just see this out of the box. It'll say open, but in this case, I also want to introduce applications. So I'm going to jump over here. When I click CML LLM application, it'll open up a new window. And from in here, you've got a Gradio interface, a couple example questions. One thing to note is that since I've only given it about 13 docs in our vector database, I want to ask questions sort of specific to those. Otherwise, you sort of lose the reason you're using RAG. The whole idea of RAG is retrieval augmented generation. So you're augmenting your search with certain types of queries that you pulled out of the vector database. So I've loaded in the information about machine learning in Cloudera and some information about iceberg. So I like the iceberg example because it's so sort of poignant, right? Like if I'm asking a question, what are iceberg tables, or what is iceberg? I actually like what is iceberg even better, because if I ask that question on ChatGPT, I'm probably going to get a response that correlates with whatever the Titanic ran into or scraped, or maybe the lettuce that no one likes to eat for lunch. But you see that play out explicitly whenever I submit the question, and I get two sets of responses, the top one being one that has no context and the lower one being one where I actually used the vector database to help facilitate that search response. And again, you see that played out like so. This one actually used Milvus, and this one did not. Think of the question that sort of got asked under the hood as, what is iceberg given this data context? And you'll actually note that if I go back into the application and look at the log files, it printed out, iceberg snippet as being the source document that I looked at. This one right here was from a query that I did a little bit ago, so that's why that's there. One last thing is around the actual LLM response. If you notice, I'm actually pulling the context chunk from the data. So I only loaded in a portion of that total data set, the iceberg snippet.txt, and I actually pass the whole document to the LLM whenever I read it in as part of that semantic search. So just something interesting to note about the size of the vector database as well. I hope you enjoyed this and got something out of it. Thanks.